Thank you all for standing by, and welcome to today's webinar, HashiCorp Vault plus Google Cloud, Creating and Managing Dynamic Secrets. Please feel free to type your questions during the webinar. This webinar is being recorded, and the recording will be made available after post-processing, usually within 2 days. Our speakers today are going to be Jeff Mitchell, Engineering Manager from HashiCorp, and Seth Fargo, Developer Advocate from Google. And now, let's get started. Jeff?
Hi, thanks, Peter. So I'm going to be taking the first part of this webinar, and I'm going to be talking about some of the major features that are new in 0.10 and 0.10.1. If I can advance my slides, there we go. So as always, major features have been added post 0.9. So there are things that won't be talked about here that if you're coming from early in the 0.9 series, you might not see. So it's always good to look back to the change logs and see what's changed. And the other part is I mentioned 0.10.0, 0.10.1. So quite often, because the major releases, we have specific time slots for them. There are some things that aren't quite finished, and we have to defer them. And so a lot of things tend to appear in .1 releases. So I'll be talking about some of those today. So the big one is that our web UI, which previously was only for Vault Enterprise customers, is now fully open source. It's built into our open source binaries. It's available to hack on, send PRs to. We're really happy about this, and our front-end engineers are also thrilled about this. So kudos to them for what they've built so far, and hopefully we'll see a lot of traction and engagement there in the future. KVV2, so our key value store, which maps kind of URI paths to essentially JSON blobs. So it's like a key, that's the value, has been completely rewritten. And we still support KV version 1, it's not going away. And that's something that you can choose for. There might be various reasons. It's a little bit faster, that's a little simpler. But KVV2 supports versioning, check and set, and delete, undelete, and destroy. And I'm going to be demoing this later, so you'll get to see all of those things. Database root credential rotation. So the database backend, which generates dynamic credentials for your databases that have a lease, that are time limited, and that Vault will revoke when they're expired. It now supports rotating its own root credentials. So when you give Vault some kind of username and password to use for connecting to the database, Vault can now rotate that so that only Vault actually knows what that current password is. Because of the way that Vault's ACL system works, its access control layers, you can grant this rotation capability if you have like a security policy that says that you have to rotate passwords every month or every 3 months. You can grant this to like relatively unprivileged actors. So you can just say you are only allowed to do this. That's the only thing you can do, is just make sure that once every 3 months you go and rotate those passwords. And I'm going to demo this as well. And finally, X-forwarded for. We've been getting asks for this for a very long time, and this is one of those things where a lot of times there are features that we know people want, we know are useful, but we can't quite figure out the right way to do it in a way that makes kind of a security sense. So we want to make sure that if we're honoring X-forwarded for, that we have a good story around how you do that safely, because it is just a header, it is pretty easy to spoof. We now have support for X-forwarded for headers for determining remote client IP. And on top of that, we've added the ability to restrict tokens so that they can only be used from specific hosts or CIDRs. And I'm going to demo that as well. These are both 0.10.1 features, by the way. The token CIDR restriction right now is relegated to token roles that come via the token auth method. Support can be added to other methods over time. Auto and seal wrap improvements. So if you're using either AWS KMS or GCP or a PKCS11 HSM for auto and seal wrapping, we can now rotate those keys. It's very transparent. You basically tell it the new key to use, and it still is able to successfully decrypt the old keys. So we're storing information about what key and mechanism was used. And so now when you're using PKCS11, we also have beta support for using ASGCM. And I say it's beta because we've only tested this on AWS Cloud HSM at the moment, but we'd love feedback from those that are running it, and let us know how it works with any particular HSM that you're running it with. And the nice thing about ASGCM is it doesn't require a separate HMAC operation, so we don't need like an HMAC key to authenticate the encrypted data. That's all part of ASGCM's mode. It's an authenticated cipher. So that's pretty cool. And because of the way that the rotation works, if you say, you know what, I want to migrate to ASGCM, you can just basically specify a new key. Vault can create that for you automatically, and it'll just start using that from now on anytime that there's a write, but still decrypt the old ones. Selective HMACking and audit logs. So on a per mount basis for a secret engine or an auth method, you're now able to say, when auditing, if this key appears in the data for either the request or response, don't actually HMAC it. And so we've seen this a lot when people have like identifiers that are useful, that they want to be able to see like, how does this audit log entry correlate to a particular like user or particular identifier in some way. And so now you can kind of say, hey, I want to keep this in plain text and track them more easily. Azure authentication. So Azure can now be used as a trusted third party to authenticate the Vault and get a Vault token. A lot of people have been asking for that, so that's good. Lots of googly things, which Seth Vargo, who is the other half of this of the presenters today, he'll be talking about later. So that's it for the slides. I wanted to keep the slides relatively short because I wanted to be able to spend some time on the demos. So give me just a moment to get the demo started up, and I will share my screen again. Okay, can everyone see? I'll make it a little bit bigger just in case people can't see it. Okay. If this is not visible, then Peter, please break in and let me know. Okay, so what I'm going to do here is I'm going to start a Vault dev server, and this is just so the configuration that's being used. The configuration that's being used, this is just a dev server where I've added an extra listener, and so that's listening on port 8202. It's not using TLS just for this demo, and this is showing the exported for. So I'm saying we are going to skip one hop, and I'll talk about what that means, and the authorized addresses. So that's saying that only localhost is allowed to include an exported for header. There are also some additional settings which are not shown here, which basically say, what should I do if the exported for header is not present on this listener? You can reject, or you can allow it, but just simply not trust it, or you can allow it. And then what if the originating address is not authorized, in which case you can either reject it or say, I'm not going to trust this, just use the IP that came in, or came in on. The other thing is just for display purposes, I have this grep remote address there, and that's just to kind of show, as I go through the demo, show the mechanism of action here.
Hi, Jeff. Could you use a slightly bigger font, please, if possible?
How's that? Does that work?
Yeah, that's a good start. We just had somebody in the question.
All right. Yeah, hopefully it won't be too large. All right. So I have I put together a shell script of commands just so I can sort of talk through them instead of taking time typing them, because there's a lot. And it's going to go through, and these are all kind of Vault commands and curl commands, and they'll be, you'll be able to see what it is that I'm typing. And just a moment, just moving this. I'm going to try and make it a little bit bigger, a little more legible. All right. Okay, so the first thing I'm doing is I'm just setting my Vault token to root just for getting things started, and I'm enabling an audit mechanism. So I'm just using file, and I'm saying send to standard out. And the reason is, you see in red here, because I did that grep the remote address. And so as I go through these commands, I'll point out some things about what the remote address is showing. All right, so right now, so 8202 is the endpoint at which I specified that I wanted exported for support. And the default is, if you say that you want exported for and it's not included, to reject it. You can turn that off, but right now you see that I made a request to it to just do a lookup self on the root token. And we see an error that says missing exported for header, and I'm configured to reject when not present. So now I'm going to add the header. So you see exported for 1.2.3.4 and 2.3.4.5, and everything works. And so the nice thing here is you see a remote address. This goes back to the hops value that you can see up in exported for hop skips up here. And so what it's saying is take one back from the last address. And so the reason that this is useful, and why we decided that this was finally the right time to do it once we sort of landed on this mechanism, is if you are an organization, what you don't really want to do is you don't want to trust exported for headers being set by anybody outside your organization. So what you can do is you can say, I have a load balancer, it's adding exported for headers. And so I'm going to allow only the load balancer address to actually set this header, otherwise I'm going to reject it. And if there's some, let's say that load balancer that's internal is also essentially behind an external load balancer for client IPs. So you can say, I want to have one hop skip. So the actual client IP is 1.2.3.4. And 2.3.4.5 might be some internal usage. And so you can basically pick somewhere along the chain, starting from the most recent, as the address that you want to use. And so it's pretty flexible, but it doesn't rely on any sort of heuristics about what's a public IP, what's not a public IP, which is pretty common. And the nice thing about that is you don't really want to rely on public IPs, because in a lot of cases, Vault is being used within an organization and is using one of the reserved private CIDRs anyways. Oh, and I should mention, you can have separate settings per listener. So if you have one listener that's coming in from external and one's coming in from like internal users, you can have different listeners, and you can just say, hey, I want to use this set of authorized addresses on one and this set of authorized addresses on the other, and have different hop skips if you want. So just to show that, what I want to do right now is I want to show that, like, if it's not coming from 127.0.0.1, which was the authorized address in my config file, that it's not going to work. And so I'm just going to pick the Docker 0 interface here, which is 172.17.0.1. And so now if I make that same request, but I pick that as the interface, so it's coming from a different client address, then you see client address is not authorized for exported for, and by default we're configured to reject connections. So that's nice. All right, so the next thing I want to talk about is kind of building on this to write a token rule and bind it to specific CIDRs. So I'm writing a token rule here that says allowed policies as default, and I want to bind it to 1.2.3.0/24. And you'll notice that that if we scroll back up a bit, scroll back up, you'll see that the authorized address is 127. I'm sorry, the exported for in the example, we did one hop skip, so 1.2.3.4 is what was used there. So I'm just creating this token rule. I'm binding it to a specific CIDR, and now I'm going to issue a token against it. So just showing that I can create a token against this with policies default, and one is successfully created. I'm actually going to rerun this just to and get a different token ID, just so I have it into an environment variable. So I'm going to do that right now. All right, so same command, I'm just exporting it into a Vault token so I can use it in these lookups. So now if I try to do that same lookup self, so note that this is going to 8200. So this is the non-exported for host. And the remote address was showing up as 127.0.0.1, but in the configuration up here for bound CIDRs, we said it has to be 1.2.3.0/24. So it's denied. And kind of true to how we generally do things in Vault, like it doesn't tell you why it's denied. You can't sort of try to work around it. It's denied. However, if I go through 8202, this is the one that has exported for configured, and I pass in exported for headers, then the configuration will skip the first, we'll skip one hop, and we'll say, okay, the client address is actually 1.2.3.4, and so the call succeeds. So this is right now, this is only supported in token roles, but the actual IP enforcement is kind of in Vault's core at this point, and so this can get plumbed out to other backends in the future. So if you have infrastructure and you want to like make sure that a token generated for a machine on one subnet can't be used by a machine on another subnet, that kind of thing will be is possible now with these, and we can work it into things like the CERDOC method and token store roles. I'm sorry, and the app role and other things. Okay, so I'm going to put the root token back for the next part, and I'm going to use the non-exported for listener just for kind of ease of use. Because the next thing I want to talk about is I want to talk about KVV2. That's our version 2 of the KV store. So there's a new Vault KV command, and we made this Vault KV command because we wanted to make it easier. The KVV2, in order to actually do all the new nice things that it does, it has to stop being sort of a dumb engine. And so the original KV is very dumb. It just says, here's a path in the URI, and that maps to a path on storage. And the problem there is we can't really build an API around that, and we can't sort of build any richness into it because we don't know what paths might be in use. We don't know what paths we might need to reserve for the future. And so, so we sort of need to start from the ground up if we wanted to add these features and have a real like API and have it map to a different sort of method of storing secrets. And so because that requires some things that are not super easy with just like the Vault write command, we put Vault KV, which does a lot of like magic for you. So it works very similarly to like a Vault write, but it's specific to the KV store, and it knows how to format the data, and knows how to read the data that comes back. So you see Vault KV put here. If you use the Vault write, we use put and get for a reason. Partly this is to mirror console's console KV commands, and it's also so that if you're just glancing at a Vault command, then if we do Vault KV write, it can be very easy to sort of look at that and not sort of think about the fact that it's not Vault write, it's Vault KV write. So we wanted to have a little bit of a distinction there to make it a bit easier to understand when you're looking at a command, whether it's a KV command or just a normal Vault write, Vault read. So you see that I put at a path of secret/dinner, Tuesday equals taco. And you see that there's created time, there's no deletion time, it's not destroyed, version is 1. So now if I do a get, then I see that same metadata, and the data comes back for a key of Tuesday, the value is taco. So now let's say I want to change that to pizza. I don't want to have Taco Tuesday anymore. So created time is updated for version 2. Deletion time is still not there. We haven't deleted it. It's not destroyed, and we see the version is 2. And if I do a get, then we see that Tuesday is now pizza. But I can still do a get on version 1. Version 1 has not gone away. So if I do KV get and give it a version 1, then we see we still have Tuesday equals taco, and we see the original created time and the original version in the metadata. Now, if I run a Vault KV delete, it will delete the most recent version. So you see version 2 now has deletion time. It's not destroyed, we'll talk about that, but it has a deletion time. And I can still get, so if I do Vault KV get, I'm sorry, up above here, you also notice that no data was returned. However, if I do a Vault KV get on version 1, then data is still returned. It's the original data for version 1. Now we can go back and say, you know what, I want to delete versions 1 and 2. And now if I go and do a get on version 1, we see that's been deleted as well. If we can do an undelete, so you can give it a set of versions to undelete. We see that we can just do a Vault KV get. We see version 2 and Tuesday equals pizza. So this isn't a way to sort of like purge the data from Vault. This is, oops, I don't really want anyone to read this because I didn't mean to, but maybe for compliance requirements, we want to leave it around because it's part of our history, or maybe we just want to be able to like get back to it if in fact we decided that we did want it and be able to like undelete it. So you can just do a delete and then figure that out and then restore it if you need. We support a max versions parameter. So this can be configured globally, or it can be configured per key, per path. So I'm doing this per path. So secret dinner now says max versions of 3. And so now I'm going to do a couple of puts to kind of demonstrate this functionality. And this is important. So, if you don't want your kind of data store to kind of keep growing and growing and growing and growing, then I think we default to 10 versions or 20 versions, I forget, globally. But, you could set that to 999,000, and you'll kind of get an ever expanding set of secrets. And so, eventually you may want to keep storage under control. And so you can set either a global or per path max versions. So I just did a put. I said, Tuesday is going to be back to tacos and Wednesday's pizza. And now I'm going to add Thursday's stew. And you'll see that if I do a KV get on version 1, we set the max versions to 3. So now 2, 3, and 4 should be live. Version 1 is gone. We actually don't have that anymore. We can't undelete it or anything like that. It's just gone because we've aged it out. There's also check and set. So you see, I'm going to, still set max versions to 3 and do a cast required. So check and set required. So check and set basically means when I'm writing this data, I expect the version to be X. And if that version isn't currently X, somebody else has written in the interim, then my write will not take effect. So I'll demonstrate this. So Vault KV get version 2, back to that. All right. Now let's say that I do a Vault KV put on secret dinner. Tuesday equals taco, Wednesday is restaurant. So going back to 2, where Tuesday was pizza, I want to update that to taco, and I want to set Wednesday. So it's saying check and set parameters required for this call. So I did not specify what version I meant to actually update, and so it's denying it. So now if I put cast equals 2, then it says check and set parameter did not match the current version. So if I read data before and I now have an outdated version, check and set is keeping you from overwriting the most recent version with the changes you made to a potentially outdated version. So now I can say, I want to get version 4. and I want to do a kv put with cas4, and now it works. Because 4 was the latest version, I did a check and set with version 4, and so now that's been accepted. We have a version 5. We also in 0.10.1 added kv patch, and so this is something that people have requested for a long time to sort of ease the headache of like pulling down a secret, modifying it, and then pushing up a secret. And the problem there is that there are a lot of ways that it's very like edge casey. There are a lot of ways you can essentially end up with data with kind of the old KV version 1. If we had this sort of patch command, you can end up with data that matches, that is neither consistent with what one writer wrote or what the other writer wrote. And so what one writer or the other thinks the end result should be is you end up with something that isn't actually, doesn't actually match what either one expected. And so we never implemented patch for that reason. We said, look, just be, do due diligence. However, because of check and set, we implemented patch here because what we can do is we can pull down data, modify it, and then write it back with a check and set. We know that that the data that we're trying to write is still that consistent full blob, and we know that if anyone has changed it in the meantime, it's not going to work. Because under the hood, the KV patch is using check and set. And the nice thing is that you don't have to turn on check and set as required. Check and set is always available, even if it's not being required for a particular path or required by the global config for that mount. So Vault KV patch is always using check and set, even if you haven't required it for a particular path. Okay, so now I'm going to do a KV get, and you'll see that we had before. Thursday was, I'd have to scroll up because I forget. What was Thursday? Thursday was stew, and we did a patch, and now Thursday is soup, but all the other values are the same. So destroy. So Vault KV destroy, if I do it on version 5, then you see that destroyed is now set to true. I can get version 4, but if I try to undelete version 5, it's not there. So once it's destroyed, you can't undelete it, you can't get it. It shows it's destroyed, the data is gone. We have the metadata about it. And there's a destroy on the metadata, which will, there's like a metadata destroy option, which will also get rid of essentially the entire key. So all the metadata and all the versions. But if you're just destroying a particular version, we still keep the metadata to let you know when was it created, what version was it, and the fact that it was destroyed. That's, the data is gone. Okay, so that's KVV2. There's other things we have kind of in the pipeline that we're thinking about, so there might be more improvements to that in the future, and we're pretty excited about it. The next thing I want to do is I want to talk about database root credential rotation. So this will be pretty quick. So I'm just starting up a Postgres container here. And because in the past, if I had gone through that too fast, the next command would fail because I would try to do it too fast. So I just have to sleep in here. Apologies. Okay, so I'm going to connect to this. Okay, so you can see that I was able to successfully type password, which is the default password, and connect to Postgres in the container. Okay, so I'm going to enable the database secrets engine in Vault. I'm writing just a database config, so I'm saying the plugin name is Postgres database plugin, allowed roles, PG role, connection URL. So, so the other thing here is, as part of this work, you see that we've now templated the username and password in the URL. And the other nice knock-on effect with this is that because we did this templating, we now have the user explicitly define what the password is. And so when error messages come back, there was a chance in past versions of Vault before 0.10 that an error message coming back from some other part of like the Go libraries or a SQL driver, like the Postgres driver, could contain the connection URL, including a password. And so now, because we know what the password is, we actually scrub that out from error messages. So you can see I can do a read and we don't return the password. I didn't specify, you can specify a root credentials rotate statement. I didn't do that just because we have a default one for Postgres, and so I didn't need to, but you can specify a custom one if you need. So I'm writing a database role, so I'm just saying the database name is PG. This is kind of the normal creation statements that we have in our example. All right, and so I can read credentials. I've connected to the database. I have dynamically generated credentials. That's a username, that's a password. And just as a reminder, I can still connect to Postgres using the password. So the value that was given in that original config statement still shows up. So now I'm going to write database/rotate root/pg. PG is the name of the database connection that I had set up. So I'm still able to read credentials. I can still issue a Vault command. Vault is able to give me a new set of username and password. However, if I type the same password back in, authentication has failed. I no longer know what that is, and only Vault does. Vault has that stored in its encrypted barrier. It doesn't divulge it, and so I no longer can actually get into Postgres. And so the nice thing is you can rotate that on a schedule. Like I said, you can give access to just particular paths for that rotation. And so it's a pretty nice way to make sure that nobody but Vault actually knows what that is. So that's the end of my demo. I'm going to turn it over to Seth. So Seth is going to talk about some of the work that that's been going on with Google, who has a partnership with HashiCorp to kind of work on enhancing integration with HashiCorp products. And they've been doing a lot of really great stuff with getting GCP features sort of integrated well with Vault. So things like secret generation and spanner storage support and all that kind of stuff. So I'm going to send it over to Seth now to talk about it. And thank you very much.
Cool. How's everyone doing today? That's fantastic. You're all muted, so you can't actually answer. I don't know about you, but Jeff's talking about restaurants and foods and tacos and cider blocks, and I'm hungry now. And it's almost lunchtime on the East Coast. Anyway, I'm here to talk about Google Cloud and HashiCorp Vault and some of the ways in which we try to make GCP one of the best clouds in which to operationalize Vault. So a little bit about me. My name's Seth. I'm a developer advocate here at Google. I've been at Google about 6 months. Prior to that, you might recognize my name. I was actually at HashiCorp, working with Jeff and a bunch of other folks on the team. So I'm pretty familiar with these tools. What I want to do here today is give everyone kind of a brief overview of all of the things that have existed in Vault prior to 0.10 or 0.10.1, which just came out, to show you kind of some of the commitment we've had in the past and some of the things we're working on in the future. So prior to 0.1, we had two storage backends for Vault, Google Cloud Storage, which is our object store, similar to something like Amazon S3, and then Google Cloud Spanner, which is our relational database that's globally distributed. And in terms of kind of the features that they support on the Vault side, the Google Cloud Storage backend didn't support things like high availability or Vault replication support for Vault Enterprise, or default application credentials, et cetera. But it was significantly cheaper than Cloud Spanner. Cloud Spanner offers, things like Vault high availability mode, support for Vault replication. It is an ACID compliant, database. You can run SQL commands against it, et cetera. That came at a slightly higher cost. So customers were kind of choosing between those two prior to 0.10, but we did have these two options available for users to choose from. In terms of ways in which users could authenticate to Vault, so similar to like username and password or LDAP, on GCP we had two primary methods which users can authenticate. The GCP auth method, the Google Cloud authentication method, which leverages a JOT token, and we also have the Kubernetes auth method, which works with the Google Kubernetes engine. If you're not familiar, the GCP auth method is very straightforward. It looks like this, and obviously, as you all know, this is also available via the API. But a client generates a signed JOT token using the signed JOT method. So they would use their service account credential or an application credential and send that to the API and get a JOT token back. That client or the user or the machine would then send that JOT token to Vault with the corresponding role name. Vault then reads the ID of that JOT token and the sub ID and the metadata to find the associated service account, validate that service account is permitted, and assuming all of that is successful, Vault will authorize the service account against the role. You'll get back a Vault token, and you'll be able to interact with Vault given the policies that were assigned to the service account. And this is pretty straightforward. If you're a machine, so for example, if you're a compute instance like Google Compute Engine or Google Kubernetes Engine, which runs on instances under the hood, it's very similar, just a little bit different. The machine actually receives its instance identity metadata. That doesn't have to be converted to a JOT token. It's already a JOT token. So that just gets sent directly to Vault with the role name. Instead of the ID pulling out user metadata like the ID in the email, it's pulling off the OAuth 2 information, and then the authorization, again, is similar. It's verified against a role. You get a Vault token with the policies attached to it. So these are two very common ways in which if you're running Vault on GCP and you want a human or a machine to be able to access Vault, that they can authenticate the same way you could authenticate with like a username and password or a token directly. If you're running in a container-based world with something like Kubernetes on GKE or your own Kubernetes cluster, you can also leverage the Kubernetes auth backend. You'll notice that it's pretty similar. You provide a JOT token. Pods and services send their JOT tokens to Vault. Vault verifies that JOT token, but instead of verifying it with Google Cloud, it's actually verifying it with the Kubernetes token renew API. And then those Vault permissions are granted based on bindings for the app and or namespaces. So those are the things that have already existed. These things have existed in a few releases of Vault now, but there are some really exciting changes in 0.10 that I want to cover very quickly. We know that there were a lot of users who are leveraging the Google Cloud Storage backend, and one of the biggest complaints was lack of high availability support for Google Cloud Storage. We had it with Spanner. Why didn't we have it with Google Cloud Storage? So I'm excited to announce that in Vault 0.10 and later, Google Cloud Storage does support high availability mode, and I will demo that in a little bit. So if you are leveraging Google Cloud Storage, you can run Vault in high availability mode, 3, 5, 7 servers. It'll automatically handle leader election, failover, etc. In terms of support for Vault replication, for Vault Enterprise, and relational things, obviously Cloud Spanner still supports those. Google Cloud Storage is an object store, so there is no kind of like SQL type way to query it, but it is available via the API. And then we also support the default application credentials now in Google Cloud Storage. And this sounds small, but it's actually really nice because it means if you're running on an instance in GCP, so if Vault itself is being managed on an instance in GCP, whether that's a dedicated instance or something on a Kubernetes engine, you can actually grant permissions to that instance to read and write from the Google Cloud Storage bucket. So you don't have to give Vault a dedicated service account. It can actually inherit the service account directly from the machine on which it's running. So this makes configuration really quick and easy, and you don't have to manage all those external service accounts or worry about rotation because they're actually tied to the instance itself. So when Vault goes to make an API call, the authentication is actually happening at the instance layer as opposed to the Vault layer. So two really cool features there. Again, high availability mode and the support for the default application credentials for Google Cloud Storage. And obviously Google Cloud Spanner still exists. It's still a great choice, but just giving you more flexibility and more choice in terms of those backend storage options. Another really exciting feature that happened in 0.10 is the support for the GCP secrets engine. So previously I talked about the GCP auth method. Auth methods are ways in which users or machines supply information to Vault, and then that is converted into a Vault token with policy. Secrets engines are responsible for storing or generating credentials. So the GCP secrets engine dynamically generates IAM service accounts based on policies. And unlike GCP service accounts by default, these IAM credentials are time-based and can be revoked at any time. So similar to how Jeff demoed earlier with the Postgres backend, when you generate a database user with Vault's database backend, those credentials have an expiration, 30 minutes, 30 days, 12 hours, whatever it might be. And with the GCP secrets engine, we can generate service accounts that expire after a period of time. So if you imagine a situation where you might have a contractor who needs access to be able to view your logs so that they can debug a situation or something, you can grant that access on a time-based permission that Vault automatically revokes, and the whole process is automated and codified. The GCP secrets engine supports both access tokens, so auth 2 based access tokens, and service accounts. So you can generate credentials on an existing service account or generate a new service account. In terms of what this thing looks like, it's exactly what you would expect from Vault. There's some upfront configuration, just like we saw earlier with Jeff's demo on the Postgres backend. You give the credentials and kind of the initial privileged root user or privileged IAM user in this case. You configure all of the bindings, and at that point, the API is just a simple HTTP GET to a path, and that path Vault will automatically go out, run the associated API calls against Google Cloud, and return the generated credential. So very straightforward, very automatable, very easy to build systems and integrate with existing systems. So those are some of the things that exist today. We're obviously working on new and exciting integrations to make Vault amazing on GCP. But I wanted to kind of quickly cover why might you want to run Vault on GCP, as opposed to maybe on-premise or something like that. The first is pretty straightforward. We have a bunch of 3, 4, 5, 6, and 8-letter acronyms. Google Cloud is certified in pretty much everything that you can possibly imagine. And we take security really seriously. I'm not trying to give you a marketing pitch. Just I know some of these things are important to different organizations, particularly like healthcare and finance. Internally, we have a dedicated security team and a dedicated privacy team, and they're different teams. They're very large, they're very skilled, they're very good at what they do. Some of them are industry leaders, and many of them work externally with things like Google Project Zero. So through Google Project Zero and through our vulnerability rewards programs for things like Google Chrome and Google Cloud, we've awarded over $2 million. And then we have outbound events. We publish a ton of security white papers. We participate in external events like this webinar. And then I always like to highlight the cool stuff. Like, this is my opinion of the cool stuff that we do. We own all of our own fiber and all of our own undersea cables. Not only does that mean that there's less hops for your data to get to you or your customers, but we also have full control. So if there's ever a vulnerability where someone is injecting malicious fiber, we're not susceptible to that because we build and run all of our own. We have our own custom designed everything: access cards, alarms, fencing, everything at the data centers. Probably the coolest thing is laser beam intrusion detection system, which is not only fun to say, but is really cool to see in action. We have the ability for full capacity energy backup at any of our data centers. And we do some really interesting things where we build our own hardware, right? Everything in our data center we build ourselves. So we have custom servers with custom chips and custom boot modules that verify system integrity at boot time. It's basically impossible with today's technology to be able to run rogue software or rogue hardware inside of our data centers. So we take security very seriously. We have some of the best and brightest security minds who think about this kind of stuff all day. So with that, I think it's appropriate to switch to a demo. So give me 1 second while I go over here. I'll make this a little bit bigger for folks. So the first thing I want to show you is that Vault is running here in high availability mode with Google Cloud Storage as the storage backend. So I'll jump this up a little bit bigger. This is the Google Cloud Web UI. I have a project here called Seth Vargo Vault Demo. You'll see that project name a few times. And here I have a Google Cloud Storage bucket. It's a multi-regional storage, but any storage amount doesn't matter. And in here you can see the standard kind of Vault setup. So I've already initialized this Vault in advance. But you can see that the auth things, the core, logical, et cetera, are all here. So this is actually running against a real Google Cloud Storage bucket, but because this is running in Vault 0.10, I can actually show you that it's running in high availability mode. So what I can do is I'll run Vault status, and what you can see here is kind of the standard HA mode output. HA is enabled, the cluster is running internally. This is actually running on the Google Kubernetes engine. So each of these Vault servers are a container running on a dedicated host or a dedicated node. And our active node here is 10.16.19. So 1.9 is going to be important here in a second. So what I'm going to do is I'm going to open up a split here, make this a bit bigger for you. So what I want to show you is the process by which the high availability recovers, right? So we have these 5 nodes. All 5 of them are running. One of them is the active. The 4 are in standby. And what I want to show you is that when that active one dies, that the leader election occurs in basically real time, and service requests continue to be serviced. So what I'm going to do here is, if you remember before, 1.9 was the active one. So I'm going to run kubectl get pods real quick, and we can see that this one's the active node here. So what I'm going to do is I'm actually going to kill that pod. So I'm going to delete the pod that is currently the active leader. But before I do that, I'm going to jump over here, and I'm just going to start a little, I'm basically going to start Vault Vault status in a kind of in a loop running every second. Let me get the, watch CPTN one Vault status. So what we should see is this will kind of update every second. When we hit the leader, we'll see a slightly different output, but what you'll notice is that right now the active node address is 1.9. So if I come over here and I delete this pod and we pray to the demo gods, we'll see the active node is currently none. And then when it updates in a second, you can see that the leader election took place and that it looks like 2.12 is our leader now. So that is the current leader currently servicing requests. Because I'm running in Kubernetes and I deleted that pod, it'll actually spin up a new pod. So if I run kubectl get pods, you'll see that there are still 5 pods, but one of them, this new pod that was just created, isn't ready. And the reason for that is it's not unsealed because they come up in an unsealed state. So I'm just gonna bring that pod back online for a second. I have this little cheater script that I wrote that will go through and make sure that all the pods are initialized. But after that, all 5 pods will be online. They're behind a load balancer that's kind of public facing, quote unquote, because only I can access it, but I'm accessing it here from my local laptop. So that's an example of Vault running in high availability mode on Google Cloud Storage. This is a pretty low cost way to run Vault in an HA supported manner. The next thing I want to show you is the new secrets engine. So the GCP secrets engine. So I'm going to go ahead and run Vault secrets enable GCP. That's going to go ahead and mount and enable that secrets engine at the GCP path, at the default path. In advance, I've created this service account similar to like a database backend where the user that is going to be generating other users has to have high privilege. Like I can't be a low-level user and generate more privilege than I have. The same is true for GCP, right? If I'm going to generate IAM service accounts, I have to have the superset of permissions that I want to generate. So I've gone ahead and generated that in advance. So what I'm going to do now is I'm going to write to GCP config. I'm going to give it the credentials, which are locally in this vault sa.json file. And I'm going to set the TTL to 1 hour and the max TTL to 12 hours. 12 hours. So at this point, I've given Vault kind of these, I don't want to say root, but very privileged service account credentials that have the superset of permissions that I would ever want to grant to this path. And next, what I'm going to do is I'm going to generate a series of bindings. So I'm going to, I have these bindings here, and this binding is very straightforward. I have my project, which if you remember from before is that Seth Vargo default project. That's the same place where the storage bucket is. It's the same place where the Kubernetes cluster is. And what I'm doing here is I'm creating a binding so that to this project with these roles, and the role in this case is viewer. So you can think that it was like basically select all on all tables, but you can't read or write or edit anything. It's just view only for everything within the project. So now what I'm going to do is I'm going to upload that binding mapped to a service account. So I'm going to write to GCP role set demo. So here what I'm doing is I'm creating what we call a role set, which is kind of like a mapping between a binding and the series of operations that you want to take place. I'm going to tell it that I want it to generate a service account key. Vault can generate, the secrets backend in Vault can generate both service accounts and OAuth tokens or access tokens. So here I'm just specifying, hey, I would like a service account instead of an access token. I'll give it the project, which is again, Seth Vargo Vault demo. And I will give it the bindings using Vault's at syntax to read from the local disk. So what this is going to do is not work because I can't type. Cool. So what this did is, and you'll notice it took a little bit of time there, is it actually created a new service account that we're going to generate credentials from in the future, mapped to that binding. So if we go over here into the Google Cloud Console and I head on over to the IAM permissions under service accounts, what I'll see is there's this new service account for Vault secrets backend role set demo. And here demo is, remember the command I ran, the name is demo. So this is the service account that was created whenever we ran that command. Right now, you'll notice that this service account has no keys. So there's actually no way for it to authenticate. It just exists. It has some permissions. And those permissions are editor on the project, or sorry, viewer on the project. So now what I need to do is I actually need to generate a key that can act as on the behalf of that service account. So I'm just going to read GCP key demo, and this will take a few seconds, but you'll notice that I get back a standard Vault credential here. This is the lease ID, the lease is renewable, etc. It's valid for 1 hour because that's the TTL associated with all of our credentials. It is a Google Credentials file, and then there's all this private key data here. And this is actually base64 encoded JSON. So if I just do one of these, I'm just going to base64 decode this really quickly. What you'll see here is that this is actually a JSON file. If you're familiar with Google Cloud, this is a service account credentials file. So I have a service account, I have a private key. This is actually a private key. And then you can see the scopes and the things that I'm able to authenticate with. Because I just showed you all of that, obviously I can revoke that early. So I'm just going to revoke everything under GCP. Oops. I used the old command, but now that service account credential is revoked. So that concludes the demo. If there's any questions, I think we'll hand it back over to Peter.
Thank you, Seth, and thank you, Jeff. So at this time, we're going to open it up for questions. You can enter them into the chat box. While we've been going, we have had a couple come in. Jeff, we had a question on Vault asking, how can you retrieve the passwords created by Vault with regards to dynamic database secrets? So for example, like using the root token.
Yeah, so you can do that by, there's an endpoint called sysraw, which basically gives you direct access to decrypt values that are on storage, and that's turned off. That endpoint has to be enabled in Vault's config file. But if you enable it, and if you have a root token to that path, or a root token or sudo to that path, then you can basically use the underlying storage path to get access to it. So it is possible. It's purposefully like a little obtuse, but it is possible to do.
Excellent, thank you.
You basically touch that storage entry. I'm sorry, go on.
No, it's okay. So this may be a question for either you or for Seth. How do you configure a Kubernetes service account to access Vault to get specific secrets that is only visible from a specific namespace?
Seth, that's all you.
Very carefully. So it's hard to explain like in text. I don't have anything available in front of me to show you, but your service accounts in the service accounts in Kubernetes are going to go to the token reviewer API. I always want to say reviewer for some reason. And when Vault is actually configured, you can configure in the auth method the namespaces as well as like the associated service account roles that you want to allow it to be bound to. So in that binding, you have to bind to a particular account namespace and the service account namespace and the pod namespace. So it's actually kind of restricted by default. I'm not sure if the bound service account namespace is, I think it's required anyway. So it's bound to a namespace by default anyway.
Excellent, thank you. Jeff, will there be a Terraform deployment module for Vault with a console backend on GCP?
That's a GCP question, so.
Sorry.
Sorry, can you say that again?
Yeah, sorry, Seth. Will there be a Terraform deployment module for Vault with a console backend on GCP?
Will there be a Terraform deployment module for Vault with console on GCP? To the best of my knowledge, there are no plans to write that Terraform module. There's no reason that it can't exist, but no, there's no plans to do that right now.
Okay, so another Google Cloud question for you, Seth. What's the current SLA for availability on Google Cloud? Like how many nines?
It's by service, and it's by the type of configuration that you choose for that service. So let's take Google Cloud Storage, for example. And I'm going to look it up real quick so that I don't mess it up. Depending on the type of replication that you decide, the storage mechanism, for example, you get a certain monthly uptime SLA. So if you choose multi-regional, which is the default, you get 99.95%. So 3.5 nines for monthly uptime. If you choose regional, you get 3 nines, so 99.9. But if you do something like cold line, which I would not recommend for Vault, cold line is more for like archive data, things that you very rarely access, you get 2 nines, 99%. When you compare that to Spanner, the Spanner SLA for a global distribution is 5 nines. So if you do a multi-regional distribution, you get 99.999. And if you do a regional instance, it's 4 nines. So Google Cloud itself doesn't have like an SLA. Each individual service has SLAs. And we actually document the SLAs for every service that is publicly available and in general release on the website.
Thank you, Seth. We did have a couple questions on here about using Vault and Kubernetes together. Where is the best place for them to find more information about utilizing Vault for a Kubernetes backend?
We do have
go ahead, Jeff.
So we do have on the plugin page for so if you're using the Vault Auth Kubernetes plugins, that's what allows you to use Kubernetes to authenticate to Vault. We have documentation for that on Vault's main documentation site, and there's some additional information on the plugins repository page, like README. If you're, I think if you're talking about anything beyond sort of that authentication method, then something more specific to like running in Google's in GCP on Kubernetes or like GKE or something, then I'm not sure.
Thank you, Jeff. Okay. We had a question come in just asking about using GCE instances to authenticate with a Vault server. Are there any, Seth, are there any different methods than the one that you showed? Like, are there ones for possibly quicker authentication, or is the auth method currently the only option available?
For GCE instances to authenticate, to retrieve a Vault token, currently the Google Cloud auth method is the only way and the most effective way. If you're running on GKE, which is the Google Kubernetes engine, you can either use the Kubernetes auth method, or since GKE runs on the Google Compute under the hood, you could also use the GCP auth method for that as well. It depends on what layer of trust do you want to establish? Do you want to establish trust with the Kubernetes API, or do you want to establish trust with Google Cloud? So that's more of like a company decision, less of a technical one.
Thank you. Okay, at this time, looking to see. Jeff, do we currently offer any Vault integrations for OpenShift?
I believe that, so I don't know how the OpenShift numbering goes, but I believe that the auth Kubernetes method should work on any version of OpenShift that's based on Kubernetes 1.6 or above. I think that's the case. That's based on sort of my understanding from having talked to Red Hat of it being essentially of OpenShift adding onto Kubernetes and not taking anything away. So if you're using a version of OpenShift that is based on Kubernetes 1.6 or above, I believe it will work.
Excellent, thank you. All right, it looks like we've handled most of the questions that are coming in. Thank you, Jeff. Thank you, Seth. Those were some excellent questions that we had from the audience. I do hope that everyone enjoyed today's webinar and has a better understanding now of how you can use Vault to manage and create secrets on Google Cloud. I really want to send a big thank you to both Jeff and to Seth for their time today. I also wanted to mention that HashiCorp is hiring. So if you liked what you heard today, please take a look at our jobs page at hashicorp.com/jobs and see if there might be a fit for you. And finally, as I mentioned at the beginning of this webinar, it was recorded and we will be making the recording available on our website after processing. I will send an email to everyone who registered with the recording link, and you can also keep your eyes out on Twitter where a recording link will be made available later today. Have a great day. Goodbye, everyone.